Assalamu alaikum. My name is Qasim Shehzad. Today we are discussing mechanical technology lecture number first thermodynamics. In this lecture we are discussing preparation and revision of thermodynamics and how to revise it properly. So let us discuss first definition of thermodynamics. So thermodynamics is the study of generation of power with the help of heat. First of all, you will says that thermodynamics is derived from Greek word in which term mean heat and dynamic mean power. Then you are have to define it. So definition is just like that it is the study of generation of power. Dynamic mean power. So it is the study of generation of power, that how to generate a power with the help of heat. हीट की मदद से पावर को जनरेट करने को हम क्या कहते हैं? थर्मोडायनामिक कहते हैं. ये हुआ इसका डिफिनीशन. फिर इसके बाद एप्लीकेशंस हमने लिखे कि ये कौन कौन सी एप्लीकेशन में इस्तेमाल होता है. ऑटोमोबाइल्स, कार, रेडिएटर, वाटर हीटर, रेफ्रिजरेटर, एयरक्राफ्ट, पावर प्लांट, मेडिकल साइंस एंड स्पोर्ट्स. Another definition of thermodynamics that it is the branch of physical science that deal with the study of various phenomena of energy transformation. So this thermodynamic is all about energy transformation, especially transformation of heat from one form to another. Its example is fuel is burned in a piston cylinder arrangement in which chemical energy is liberated from the fuel and is used for getting the shaft work for crankshaft. ये एग्जाम्पल है गाड़ी का, जो फ्यूल बर्न करता है पिस्टन सिलेंडर में, फिर उससे केमिकल एनर्जी कन्वर्ट होती है काइनेटिक एनर्जी में, और फिर ये काइनेटिक एनर्जी किस चीज़ में तब्दील होती है? शाफ्ट वर्क में या रोटेटिंग में, जो शाफ्ट रोटेट कर रहा है. जैसा कि केमिकल एनर्जी of the food is converted into mechanical energy in human body. Light is converted into food energy in plants, and the fuel, that is chemical energy, is converted into motion, that is rotating of car wheel, and electrical energy just like heater. So they are converted electrical energy into thermal energy. So form of energy will transfer from hotter body to colder body by virtue of its temperature difference between the bodies. It is the definition of heat. What is the definition of heat? Form of energy will transfer from hotter body to colder body by virtue of its temperature difference. First law of thermodynamics, its relation between heat, work and change in property of a system. It is the energy transformation in many appliances, heat water by solar, air jet, refrigerator. It is example. हीट एनर्जी का हमने डिफिनीशन पहले किया. ये दूसरा डिफिनीशन है. इट इज़ द एबिलिटी टू कॉज चेंजेस, और इट इज़ द एबिलिटी टू कॉज it is the ability to do work. Its SI unit is Newton meter. 1 calories is equal to, इसका डिफिनीशन मैंने यहाँ पर लिखा है, 1 calories is equal to, when we 1 calories is the amount of energy to raise 1 gram of water, to raise the temperature of 1 gram of water by 1 degree centigrade. 1 calories is the amount of heat, 1 calories is the amount of energy which are required to raise 1 gram of water temperature by 1 degree centigrade, and 1 BTU is the amount of energy which are required to raise 1 pound water temperature by 1 Fahrenheit. So this is its definition. 1 BTU is equal to 1055 joules and 1 calories is equal to 4.184 joules. Now what is primary dimension and secondary dimensions? Primary dimensions are those dimensions which are derived, मैंने यहाँ पर लिखा है, primary dimension that are taken from base physical quantity is called primary dimension, and dimension that are taken from derived physical quantity is called secondary dimension or derived dimension. Next question that arises is what is its energy and what is its types. So there are two basic types of energy, macroscopic energy and microscopic energy. Macroscopic energy, its definition is a system possesses energy as a whole with respect to some outside reference frame. A system possesses energy as a whole with respect to some outside reference frame is called macroscopic energy. like potential energy and kinetic energy. Then potential energy is the energy of a body due to its elevation from the reference frame in a gravitational field is called potential energy, and kinetic energy is the amount of energy, the energy that associated with the body due to its motion is called kinetic energy. So the combination of these two energy gives us macroscopic energy. Another is microscopic energy. Microscopic energy is the sum of all the microscopic form of energy. It lies in the system internal energies, which contain molecules have transitional, rotational, vibrational. This energy is called sensible energy. Now let us discuss types of microscopic energy. So there are four types of microscopic energy. First one is latent energy. Latent energy is the energy required to break the intermolecular forces of the molecule. The energy required to break the intermolecular forces of the molecule is called latent energy, and latent energy is associated with the phase of the system because it changed the phase. Phase is like system solid is converted into liquid and liquid is converted into gas. So this is called phase change. So this energy can cause phase change. Chemical energy is the energy associated with the bonds in the molecule. Chemical energy, energy associated with the bonds in the molecule, is called chemical energy, and this chemical energy is associated with the reaction between the molecule. Mean chemical energy cause the reaction between the molecules. Third one is nuclear energy. Nuclear energy associated with the nucleus energy, like the attraction of nucleus due to proton, neutron and electron. And fourth one is sensible energy. Sensible energy is the system associated with kinetic energy of the molecule. Sensible energy is also kinetic energy, but it is microscopic kinetic energy. There are two types of kinetic energy. One is the macroscopic kinetic energy, that are we assume it with respect to some outside reference frame, but kinetic energy of microscopic, like kinetic energy of the molecules within the fluid within the system. So this is called sensible energy. Sensible energy contain transitional, rotational, vibrational motion. These all motions of a particle in a fluid is called its sensible energy. So now we are discussing that the energy, total energy. What is total energy? So total energy is the sum of the macroscopic energy plus microscopic energy. So we are discussing that macroscopic energy are two types: potential energy and kinetic energy, and microscopic have internal energy. So the sum of these types of energy gives us total energy. So we consider that total energy is equal to kinetic energy plus potential energy, that are from the macroscopic energy, and internal energy, that are from the microscopic energy. So these all are the sum of all types of energy. So that's why it's called total energy. So kinetic energy is equal to half mv square, potential energy is equal to mgh, mgz, plus internal energy. Plus this internal energy also contain four types of energy that I will already said to you. That's latent energy, contain chemical energy, nuclear energy and sensible energy. These all energies are lie in the internal energy. Now we are moving toward the system. What is system? System is a quantity of matter or region in a space surrounded by a boundary chosen for study. Mean system is a imaginary or real boundary in which there is some matter or region of space within the that boundary. Or just like we says that it is a region in a space surrounded by a boundary, which have a clear cut boundary or imaginary boundary, and we are chosen it for study. So this is called system. Now there are basically two types. There are basically two types of system: open system and closed system. Another one is isolatory system, but this system include in the closed system. So we are discussing now types of system. So first of all, we are studying about the Newton. Newton is the amount of force required for 1 kg mass to accelerate at a rate of 1 meter per second square. When you have to elaborate the definition of 1 Newton, so 1 Newton is the amount of force required for 1 kg mass to accelerate at the rate of 1 meter per second square. And 1 Libra force is equal to amount of force required for 32.174 Libra mass to accelerate at a rate of 1 foot per second square. Same is the above, but there is the difference between its mass. There is kg, there is Libra mass, and there is 1 meter per second square, there is foot per second square. Now we are moving toward the surrounding. Surrounding is a mass or region outside the system. All the region or space outside the system is called surrounding. Everything external to the system is considered to be part of its surrounding. What is called boundary? Boundary, the real or imaginary surface that separates system from its surrounding. Boundary of a system can be fixed or movable. So boundary is the imaginary or real surface which can differentiate, which can separate the system and surrounding from each other. So boundary of a system can be fixed or movable, or may it fixed or may it movable. Just like we are taking a container in which there have a head and they are movable piston. So this is called boundary that are not fixed, that are movable. Now we are moving toward the closed system. What is closed system? It is also called control mass system. This is a system in which no transfer of mass across its boundary. So this is the definition of closed system. Another definition is a system that does not allow transfer of matter in or out of the system. In or out of the system is called closed system. A system that does not allow transfer of matter in or out of the system is called closed system. System does not allow matter to enter or leave, but does allow energy to enter or leave. So these all are the definition of closed system. Which one you will have to favorite or you will have to favor it, so you will have to memorize it easily. Example of closed system: a closed jar placed in sunlight. A closed jar placed in a sunlight. Or you also say that a closed pot placed in a sunlight closely. Closely not. A closed jar placed in a sunlight. But it's enough. Isolated is a special isolated system. Isolatory system, a special type of closed system that does not interact in any way with its surrounding, when there is no entering or leaving the matter and energy. So this type of system is called isolated system. The example of isolated system is a thermos flask, either cold or hot, but they did not interact with its surrounding. So that's why it's called isolatory system. Now we are moving toward the open system. It is also called control volume system. A system that can allow both mass and energy across the boundary of a control volume is called open system. Or another definition: a system that can allow both mass and energy across the boundary of the system. A system that can allow both mass and energy across the boundary of the system is called open system. Its example is automobile engine, air compressor, turbine. Now we are moving toward the property. What is property? Property of a system is to describe its behavior and how they are related. Property are those type of system. Property is to describe its behavior. Property is a phenomena which shows us that how to describe its behavior of a material and how they are related. Like pressure, temperature, volume, mass, these all phenomena shows us the property, shows us the behavior of that matter. Equilibrium. What is equilibrium? Equilibrium state is one in which all the bulk physical properties do not change with time and are uniform throughout the system. This is a system in which the physical properties does not change with time. Mean there is no change with time and they are uniform throughout the system. So this is called equilibrium. Mean there is a balancing between the two matters or the two systems. Thermal equilibrium. Thermal, it is an equilibrium state where temperature is same throughout the entire system. This is the most easiest and apparent example to be memorized. Mechanical equilibrium, it is the equilibrium state where no change in pressure at any point of the system with time. There must you will have to focus on it that with time it is very important. Another in thermal equilibrium we did not says that with time, but in mechanical equilibrium we says that equilibrium state with no change in pressure at any point of a system with time. Working fluid, a matter contained within a system can be liquid, vapor or gas is called working fluid. इस लिक्विड वेपर और गैस को जो कंटेनर में है उसको वर्किंग फ्लूइड कहते हैं. स्टेट किसी कहते हैं? कंडीशन ऑफ अ सिस्टम विच डिस्क्राइब इट्स प्रॉपर्टी इज कॉल्ड स्टेट ऑफ अ सिस्टम. स्टेट्स मीन हालत. कंडीशन ऑफ अ सिस्टम विच डिस्क्राइब इट्स प्रॉपर्टी इज कॉल्ड स्टेट ऑफ अ सिस्टम. दिस इज ऑल अबाउट टुडे लेक्चर. थैंक यू वेरी मच.